Okay, so our goal here is to order these numbers on this number line, right? So you want to place all of them in their appropriate locations. I would start with numbers that are easy to work with. Like, I noticed there's the square root of 4 here, and the square root of 4 is just 2. So really, I want to rewrite this one as 2. That'll be a little easier to work with, right? And what else do we have? Well, as I scan through here, 2 and a fourth, I'm going to write that as a decimal because I have so many numbers here as decimals, I want to keep them in that form. So 2 and a fourth is 2.25, right? 1/4 is 0.25, or 25 out of 100, or 1/4. Down here, -2/4, notice I have negative numbers here. That would be what? Well, it would be negative 2.25. 4 over 2, well, what's 4 over 2? That's just 4 divided by 2. 4 divided by 2 is just 2. So this is also 2. So actually, these two numbers are the same. So I don't need to really plot them twice. I just need to be aware that the same number is written in two different ways. And I think the last really straightforward one, aside from 4, which equals itself, is -4 over 2. So that you can think of that as -4 divided by 2, and that's just -2, right? A negative divided by a positive is a negative. You could think of that also as 4 divided by 2 times -1. This negative sign could be distributed after you divide. It could be distributed to the numerator or denominator. You'll always get -2. Try it out to see what happens, right? So here, when you plot on a number line, you want to get a sense of your range, your highest and lowest values. So I noticed that the highest value here is 4. And I noticed so far the lowest value is about, well, -2.25. Here I have -2.3. So I'm going to take the range from -3 up to 4. Right? I want to make sure I get those in here. So I'll place 0 right here. And then we have, let's say every 2 will be 1. So that's a half. This is 1, 1.5, 2, and then 3, and then 4. And same thing here, except with negative. So this is -1, and then -2, and then -3. I'll fix that one. -3, and then -4. Okay, so we can begin to plot. Square root of 4 is 2. Well, let me use blue here. So this point right here, that is the square root of 4, or 4 over 2, right? That just goes right there. Okay, then what? So these two, I want to cross them out as I go. That equals 2. And so does this. Don't need to use it anymore. 4 is itself. Let me plot that one here. That's just 4. And then 2 and a fourth I can take care of next. So if this is 2.5, 2 and a fourth would be precisely halfway between 2 and 2.5. Right? That's where 2 and a fourth lives, or 2.25. Okay, that one's done. And -4 over 2, that's -2. So I'm going to plot that over here. I'm going to change colors, use purple or something. So -2 is right here. And this I'll label as -4 over 2. Okay, got that one. And I have -2 and a fourth. -2 and a fourth, where is it, right? Well, be careful, don't plot it here, right? That's not where it goes, because that would be -1 3/4. Think about where, you know, if a number is 2 and a quarter negative, it's going to be past this -2 over here. I would plot it maybe like right there, halfway between -2 and -2.5. So that's -2.25. Now you might get stuck in this scenario, right, where it's really difficult to plot these numbers because of the spacing you have. That's okay. I would just be clear about where these numbers are. What happened to me is I have this number here, -2.3, and it's slightly to the right of -2.25. So I might even label it down here this way. So that's -2.3. Now 2.3 is just going to be the opposite of that, and also really close, but right, my scale a little bit off. I would like it a little bit more to the left, right there maybe. Here, this is a 2.3. Those should be an equidistant value from 0. They're the same distance from 0. They're opposites. A couple more to go. 2.09. Where is that? Well, if you can still follow my diagram, right, this is 2. This is 2.25. So 2.09 is between that, a little bit more to the left. So here, 2.09. Now 5 over 2, well 2 goes into 5 twice, right, with a remainder of 1, or 1 out of 2, which is 2.5. So 5 divided by 2 is just 2.5. That's right here, 2.5. Okay, now to the ones that we're really concerned about, that we're thinking about in mathematics right now, is these square root numbers. The square root of 2, where does that live, right? Well, the square root of 2, let's write it over here, is some number. It's some number bigger than 1. How do I know that? Well, I'm trying to get a number squared that gets 2. But 1 squared equals 1. So that 1 is too small of a square root for 2. And 2 is too big, right? Because 2 squared is 4. But this is valuable because now we know the square root of 2 lives between 1 and 4. But because of the precision of our graph, we need to know, of our number line here, we need to know a little bit more about the square root of 2. We know it's between 1 and 2, right? I wrote 4, sorry. Between 1 and 2. Some decimal in there. But can we go a little bit further? Well, you want to test other decimal values. I know that the square root of 2 is closer to 1. And I know that because 2 minus 1 is only 1 away. However, here 4 minus 2 is 2. So there's a greater distance between 2 squared, right, and the square root of 2 squared, and than there is between 1 squared and the square root of 2. Sorry, I said the square is 2 squared back there. Anyway, so what next? Well, let's try 1.4. 1.4 is closer to 1 than 2. And 4 squared, I think of 14 squared, and I use that. Well, 14 squared equals 196. 1.4 squared is going to be 100 times smaller than that, or 1.96. That tells me that 1.4 squared doesn't quite get you 2. It's a little bit too small. So the decimal representation of radical 2, we now know, is greater than 1.4, right? Because 1.4 squared is too big. So is it less than 1.5? The answer is yes, and we can show that really quickly in the same way. 1.5 squared, you can think of 15 squared or 225, so it's 2.25. So 1.5 squared is too large. So you have some decimal between 1.4 and 1.5, which is more than accurate enough for us. I'm going to say, I'm going to mark it right here, 1.4, and the square root of 2, as you approximate, it's about 1.41, let's say. But that's where it lives, right there. Last one, square root of 5. Where does the square root of 5 belong? Well, square root of 5, we can kind of reason in the same way. The square root of 5 is, let me change fonts there. Square root of 5, we can truncate it. We can find out where it lives. It's greater than 2, right? 2 squared equals 4. We need to get 5. But it's less than 3, the next whole number. 3 squared is 9. That's too large. So what decimal between 2 and 3 squared gives you 5? Well, again, 5 is really close to 4, so I'm going to pick a decimal that's closer to 2 than 3. So let's try one. How about 2.3? So you want to square 2.3. So I want to do the long multiplication here. 2.3 times 2.3. 3 times 3 is 9. 3 times 2 is 6. Add a place value. 2 times 3 is 6. 2 times 2 is 4. Add all this up. I have room over here. So it's 9, and then 6 plus 6 is 12. Carry the 1, it's 5. But really, it's 100 times smaller than 529. So it's 5.29. That means what? Well, 2.3 squared is greater than 5. So the square root of 5 is less than 2.3. And is it above 2.2? Well, we can test it. Let's do it over here. 2.2 times 2.2. 2 times 2 is 4, or 2 times 2 is another 4. Carry the place value. 2 times 2 is 4, and 2 times 2 is 4 again. So that's 484, or in this case, 4.84. Right? We carry those decimal places. So it's greater than 2.2, but less than 2.3. So we know the square root of 5 lives between those two values. And unfortunately, on my graph, which is extremely messy, right, we can't tell exactly where to plot it. And at this point, I don't really want to test if it's above 2.25, and I wouldn't ask you to do that. But you can do it in the same way. Square 2.25, see if it's above or below square root of 5. So we're going to estimate here, since we're estimating anyway on this graph. And the square root of 5 is between 2.2 and 2.3. So it's about here. Okay. Square root of 5. All right, hope this helped.